Okay, so hello everyone. Today we are gonna see about format preserving encryption, or also known as FPE. So if you see in today's interconnected world, business almost rely on vast amount of sensitive data. It may be in any form. If you see some real life problems, like it might be credit card numbers, medical record IDs, social security numbers, and many real life things like our healthcare. But if you see, encryption often breaks the original format, which causes huge headaches and databases and applications. So today we are going to see how a format preserving encryption on FP protects this data while keeping it in all the formats legacy system requires, with example from banking, healthcare, data science, digital commerce, e-commerce, and furthermore. So let's dive deep into FP. Okay. So let's okay. So now we see what is the need of FP. We're going to see some real life problem. Okay, so let's start with the bank. So when banks first tried to encrypt the credit cards, they were shocked because the encrypted value stopped matching the expected 16-digit scheme. No, no, like a credit card has 16-digit number. See, encrypted card are no longer a 16-digit number because it system failures. So what happened? Imagine if every time you try to protect the data, to your entire business application refuse to run. But FPE solves this by making encrypted credit cards they still look like and act like a valid card numbers. So it keep the old software and modern security together. So same thing like that. This means encryptions can break the data from a system like this is a credit card example. It demand compatible encryption to ensure the smooth running of the operation with the old software and modern security together. Okay. Let's see the next thing. So we have done the intro about this FPE and some real life problem also. Now let's see what is actually the FPE. So what exactly is format preserving encryption? So if we see in the simple terms, so it is a technique where encrypted output matches the format of the original data. Okay. So for example, if we take a credit card number is like this, 43219. Okay. And it might be encrypted like this 560. So both are 16 digits. Both pass system checks, but only the real one gets you into the bank account. So the power here is preserving usability while locking down the price. So this you need to understand. Okay. Same thing now. Okay. Now the thing is that okay, we already have AES, DES of a standard encryption. Then why we have not used them and we have moved towards the FPE? So our traditional ciphers like AES, they're designed to produce completely random looking output, often longer than the original. But if you see the example we have taken of a bank database, so it expects the card numbers to be 16 digits. And AES encrypted output simply won't fit it because it breaks joins, queries, and validation logic. So what format preserving encryption does it? It reduces the cost and disruption by keeping the encrypted data in the same format. Okay. And which saves a million for companies with critical legacy systems. The same things are done here. Okay. Okay. If we move on to the next thing, that is how FPE works technically. Okay, so we have always studied a fiscal data structure, if we all remember, when we are doing our AESDs, there we have studied. So FP commonly uses fiscal network structure with multiple rounds of processing. You remember there are multiple rounds of processing and the key generation happened there. Okay, so FP algorithm often uses fiscal network. So a system also found in DS encryption, DS is where the data is split, swapped, the data is being split, swapped, and processed through encryption, cryptographic encryption rounds. And when you go like this, it will be encryption will happen. And when you go like this, decryption will happen. This happens. So here what happens, this transformation is reversible only with the correct key. If you use the different key, you will not get the answer. And every output is carefully checked to stay in original format. And later when you do the encryption and you do the decryption, whatever the input you have given, you should match that. So whether it will be number, even custom pattern, or anything, it will be checked to stay in the original format. So this method guarantees both security and format, which is rare in cryptography. So that's why it works on the facial structure. Okay. Okay. Now we'll see some industry standards and some algorithms. So if you see, you already know about NES, you've heard of many times. Okay, so to drive the universal adaptation, this standardize FPE and FF1, okay, FPE and FF1 and FF3-1 algorithms. So if you see the example of Visa and MasterCard, they require these for compliance with their network. And if I say actually the in around 2017, key update was moved from FF3 to FF3-1 after the researchers discovered the vulnerabilities is there. See here. The standard discovered vulnerabilities led to the improvement in FF3-1. Okay, so after they discovered the vulnerability, this shows that how real attackers influence cryptographic evaluation. See, banks and payment processors now rely on this standards to encrypt billions of transactions each day happen. So that's okay. Now we see how FPE is used in our real life applications. Maybe it related in banking sector, in healthcare, in retail or e-commerce, data science, all this. So let's start with the banking. So let's imagine a regional bank upgrading its payment security. So their old system was coded in COBOL. The old system was coded in COBOL. So that choked with AES outputs. But when they started using FP, they encrypted all their card data and kept all the data, but still they're able to pass every audit, every transaction. And customer never noticed. See, compliance officers slept with them because it has been made easy for them. And developers avoided rewriting the programs written decades ago. So this FP has been termed as it has been acted as a bridge between the innovation and legacy tech. Next application is Happy for healthcare data protection. Okay. I think now you all might know about HIPAA. HIPAA as far as it's a health insurance portability and accountability. Okay. So what happens in hospitals, the records of the patient, they carry the life-saving information, which include like a patient ID. It should be must be protected by HIPAA. HIPAA is it's a health information, health insurance portability and accountability. See, so it must be also recognized by medical workflows. So in encryption, if you see what happened, you broke the format of these IDs. Medical staff would wait this time, risking the safety and privacy. So this FE lets encrypted patient ID pass through every system, staying the valid while shielded from cyber criminals, and it's a silent hero in healthcare. If you need to describe it, you can say it's a silent hero in healthcare. Okay. One next real life example is format preserving encryption in e-commerce and retail. Okay. So if you see in e-commerce, what happened, whenever you go to any website, like any of the online website, you share your data, like your address, your phone number, your mail ID, all the things. So in an e-commerce system, we routinely share store validate phone numbers for shipping and masking of this data with the FP, which allows fraud check, order lookups, and communication flows without ever exposing to the real number. It underpins privacy in places customer never see, but where the security is vital. Okay. Now this comes is technical Java. Okay. And is that domains, predicts, and alphabets. Okay. So if you see, you can encrypt just about anything with the FP, like all digits, specific letters, or you can just see some custom mixes like license plates, passport codes, anything. Okay. So first is like our domain. So the domain is a define the rules for the validator. Basically, it defines the rules for the validator. While the radix is a set of alphabet, and at the end, if you see FP output always fits the space, letting all the information technology teams future-proof their systems as a new data formats emerge. Now we are going to talk about some strengths and weaknesses of FP in real practice. So FP's top strengths includes first is seamless data integration, because it has seamless database integration because no code rewrites, no schema breaks. Plus, it also has fast regularity compliance and saving migration costs. Regulatory compliance and migration costs, saving migration costs. Business keep their operations stable while taking privacy seriously, which unlocking new analytics and passing security audits with the less pay. This is some strengths of FP preference. Okay, now we're going to see about some weaknesses and security considerations. Okay, now if we see FP is very secure for large domains. We have already seen about the 16-digit credit card wala thing. But if you use for small formats, like 16-digit credit card number is there. But if you see about ATM pin, it's a 4-digit. So such as 4-digit pin is here. So then it will be vulnerable to brute force attack because it's just a 4-digit. The attacker can try again and again, and it can get the key. So which can it can break. So also misuse of poor key management can expose the system. So that's why the standards matter and why every department should consult cryptography expert. Okay. Next is FP for legal compliance. Like PC, HIPAA, DSS. PC is our payment card industry. HIPAA we already studied. Purpose of regulation on demand, encryption of the field level, like card numbers and health IDs. Our FP helps business adopt strong security and pass PCI, DSS, our HIPAA under audits without pressuring all our IT teams to overhaul everything else. So it has become a legal necessity, not just a technical upgrade. Okay. Next is database migration and clouds. So there are many cloud platforms. You already know about AWS and all. So as company migrate their data to the cloud, because cloud you can store anything. Because companies also have a lot hard about the data, and they don't have that much storage to store everything in the system. So now they started storing many things on cloud. And you also know the example of Google Cloud. Earlier you used to do in your system, but now yeah, used with our Google Collaborate. Like everything is stored on the cloud and everything is online. Same happens with the GitHub repository. Instead of saving on the system, you push it on GitHub, so it will be saved on the cloud. Okay, so that's like so as company migrate the data to the cloud, our app feed let them encrypt rows and columns without breaking the app logic. Okay, because like cloud API even include FP as a built-in function, empowering secure operation for bank, hospital, and retailers moving the legacy data to the modern platform. Next is FP for data science and AI. So if you see in data science domain, privacy law restricts the real data sets for training. Okay. And FP lets the team use encrypted format to validate samples for analytics and AI models, which helps in detecting the frauds and or trends without ever seeing a real customer credit card or ID. So it strikes a balance between privacy, compliance, and progress. Now this is something you can see. Okay, what is the difference between FP and tokenization? So if you see from format, this is FP is preserved, it is similar to reversibility, it is key-based, it is lookup table dependent, performance efficient scalable, that is lookup dependent, like compliance meets PCI, GDPR, and it's for suitable for PCI DSS. Okay, we see for summary of this table is actually what key what happens about tokenization replaces the data with the reference tokens and it requires a central lookup for reversibility. Okay. On the other hand, we see FTE is cryptographic. This data can be reversed by authorized agents with the help of keys, and there is no central vault. Okay, if there is a high volume data, real-time processing, FPE is a clear winner for isolated card vaults. Tokenization still, but don't forget, tokenization still has a place. Okay. Now, what are the FP attack scenarios and what are the countermeasures you can take? We have seen the short form. FP works well on 16-digit number, but when it comes to a PIN, which is a 4-digit, it might be a problem because brute force attack can be effective. So attackers may use some code blocks of brute force to catch the values in a small formats. See, FP overall in large amounts, 16-digit card is impractical to attack, but smaller pieces like our 3-digit coders or ATM pins, it should be combined with other protection also or avoided. So security in the deployment details. Hmm. Now, next is real world trend and research in FPE. Okay. So what happened is like we are not at all developed in the field of FP. So FP is adopting to new data type, like our first, this is Unicode characters and emojis for global apps. Then there's a research on rapid encryption for IoT devices, and there's a regulatory changes drive ongoing improvements, which keeps FP relevant as technology and privacy evolves. Okay, that we are coming to the end of this FP. So to sum up all this, I'll say a format preserving encryption allows business to protect the sensitive data, stay compliant, and support legacy apps without an operational disruption. It's used everywhere. Like critical data meets real world needs. So financial transaction security, private medical records, safe online orders, and effective cloud migration. So this all runs under FP. Okay, so we that the end of this FP, and I hope you got it. Answer. Thank you for the patience.